An airplane is heading north at an airspeed of 650 kilometers per hour, but there is a wind blowing from the northeast at 40 kilometers per hour. Then they ask the plane what will, the plane will end up flying blank degrees off course. And then the next question they ask is the plane's speed relative to the ground will be this. So I know they're using like different words to ask it, but they're just looking for the resultant vector. You know, these two vectors. What is the sum of those two vectors? And what is what is the magnitude? That's going to be this plane speed relative to the ground will be the magnitude of the resultant vector. And what's the angle? Well, it's going to be not exactly what we not exactly the angle we find when we find associated to a vector, but it's close to it. So we're just going to find, once we add these two vectors together, we're just going to find our r and theta, and we'll be pretty much almost done with this problem. So let's try to draw the situation. And it's important here to get the directions correctly. So an airplane is headed north at an airspeed of 600 kilometers per hour. So it's going, let's call this direction north, and let's just draw a little compass over here. Or I'm sorry, a little label here. North, south, east is to our right, and west is to our left. Okay. So there goes 650. They're going that speed north. And then there's a wind blowing from the northeast. So it's coming from the northeast. So the northeast would be like up here, and it's going this direction, if you will. So that means it's going to come like this and go this direction. Not exactly. It's going to be at 45-degree angle there. Trying my best to draw 45. And at a speed of 40. So our resultant vector, we need to sum those two vectors up. That's why I put that 45-degree angle with the magnitude of 40 at the start of that angle. At the start of that vector is beginning at the end of the other vector. So then if I go from the start of the original vector to the end of the second vector, then that's my resultant vector, and that's what we want to find. So you find the magnitude of that vector, then that will be the speed, the ultimate speed that the plane will fly. And also the other thing that we want to find is we want to find this angle, because it was going straight north, and then now it's going on along the red line. So we want to find the angle between where it was going and where it now is going. So we want to find that angle theta. So first, it's best to turn, if I'm going to add these two vectors together, it's easiest to add them in component form. That is, you break it down to and write it in its horizontal and vertical components. So the 600 vector going north, that's easy. It's just going in one direction. So it's going 0, it's not going to the left or right. So it's 0 for your horizontal component, and it's 650 for the up and down component. And it's positive because it's going north. We'll say north is positive, and east is also positive. So the next vector, it takes a little bit of more to think about this vector, because it's not exactly going up or down. So it's not just 0, a number. It's going a little bit to the left, right? Because it's north and east. So it's going a little bit to the left and a little bit down, right? So now this is something interesting to understand, is every vector, like let's say I have a vector, I could draw it like this. The horizontal part of that vector, if I make a triangle, if I form a triangle of two vectors, here, the horizontal component of the vector and the vertical component of that vector, they're easy to find because it's just the original vector. If this is 40, then the vertical part is just going to be 40 times sine of the angle that is in this triangle. So if this is theta, then it's 40 sine theta. And then the horizontal component, it's just easy. It's just the magnitude of the vector times cosine. The cosine is known as the x coordinate. So it's a horizontal coordinate. So that's a fast way to always, it's always your magnitude of the vector times cosine of the angle. But when you draw and you make a right triangle down with the, the x-axis, yeah. Or you just make a right triangle from out of the vector. So that's what I'm going to do here. In our picture, it has a vertical one going down. So that value is going to be 40 cosine of theta. So we do know, since it's coming in like this from the northeast, there is a 45-degree angle here, and you can kind of see it easily. The vector that's coming directly from northeast to the origin is going to make a 40, it's north and east is right in between both north and east. So it's going to form a 45-degree angle with due east. So we could write a 45 degrees right here. We do know this is 45 degrees if I draw a little line in for the horizontal component of this vector. We have the horizontal component of that, the 40 vector, and then we have the vertical component, and so this is going to be 40 sine theta, sine of 45. And the horizontal vector there is going to be 40 sine of 45. Actually, notice because it's going down, it's going to be negative, and because this is going left, it's going to also be negative. So that's what I'm going to write it. I'm going to write the horizontal component is negative 40 sine 45. And the vertical component is also the same thing, negative 40. Right, so to find the resulting vector, we just have to add together the horizontal components and the vertical components. So the new vertical components would be 0 plus this negative 40. So it's just going to be negative 40 sine 45. And the horizontal component, you're going to have to take 650 and then subtract sine of negative 40, or subtract the negative 40 sine 45. So I'll calculate with that in my calculator. Or I'll write it out what I mean here. I mean, this is our resultant vector, 650 minus the 40 sine 45. Now, something I am not going to do is I'm not going to do 650 minus 40 and then multiply by sine of 45. I'm not going to do that. I'm going to do 40 times sine of 45, find out what that number is, because the multiplication comes first. There's subtraction here and multiplication. I have to multiply these two numbers first before I subtract. So and I can usually put this, I put the negative 40 sine of 45, making sure I'm in degree mode, in first, and then I can just always add the 650. So I get 621. And then now I just calculate what's negative 40 times by cosine of 45. And that gives me negative 28. So that's my resultant vector. So what I need to do now is find my r and theta that are associated with this vector. So basically, this is the horizontal and vertical components of that vector. So now I'm going to say, well, r, the magnitude of this vector, and that's the wind speed they're asking for, is equal to the square root of the horizontal components, the negative 28.28. And of course, I have to make sure. Okay, so then I solve that and I get r is equal to 622.36. So that is the wind speed that they're talking about. Now, you see that this vector, this red vector, that's the resultant vector that we just found has a length of, or a speed in this situation of 622.36. Now, what we need to do is we need to find any angle that would be associated with that vector as well. So there are two angle, there's, this is the horizontal component and this is the vertical component of that vector. And so that's why this component's negative 28 and that component is 621. So when I find what I can set up is I can say, when I use this equation, theta, and I do the inverse tangent of typically what we would do if it's a vector is we would do the inverse tangent of y over x. The theta, and I'm not gonna call it theta here because that's usually the variable that we call it, but I remember calling the other angle theta. So this angle that is formed by drawing in the triangle by drawing in your horizontal and vertical components, it's right here. Notice how the angle alpha, the opposite is going to be the side 621 over the adjacent 28. So that is the angle that we're going to get when we use this equation. We're going to get this alpha. Now, I like to think about it this way, that like the negative 28 is only negative here because of the direction we're going in. But I'm not really that interested in the direction we're going in at this very moment. I'm just interested in what this angle is. So I'm just going to ignore the fact that it's 28. And I'm just going to do the positive 621 over 28. And that's because I'm not necessarily wanting to find that angle in standard as measured from standard position. I just want to find the angle as I see it drawn in the triangle here. And we can worry about getting it from standard position later. That's why it's okay here, but I just ignore the negative. I do inverse tangent of 621 divided by 28, and that's 87. So it's telling me that the angle here, the alpha, is 87 right here, which doesn't look like 87. It sure looks like 45 by the way I've drawn it. That's 87. So it was originally going straight north, which is straight up here. And now they're saying that the angle it's making between the x-axis and the resultant is 87. So how far away is it from going straight north? You just do 90, because this is a complementary angle. This theta angle, the angle I really want to find, that's the difference between where it was originally going straight north and the direction it now is going, which is along the red line. That is the angle between them. The direction they were going and the direction they are going now. This theta that I have, that's the angle between them. And when we do the inverse tangent, it gave us the 87 degree angle, because that's the angle that's opposite, and with these 621 and 28 would have been opposite adjacent to that angle. So we were able to find that angle, but now we have to recognize that due east, which is the x-axis, due west, which is the x-axis, and due north are 90%, 90. So these two angles are complementary. So all I have to do to find the angle I really want is take the angle I found and subtract it from 90. So I just do 90 minus my answer, and I get this 2.58, which just rounds to 2.6. I think I'm a little bit, you know what I did? I think I made some, I didn't carry my decimals probably as far as I should have. We should have added these decimals, 0.28 in here, and, oh wait, 0.72. I think my answers here are a little bit off because I didn't not using these decimals. Okay. 7.2 and 0.28. Since those are not my final answers, I definitely should not be rude. So let's try that. Let's retry that again. So inverse tangent 621.72 divided by 28.28, and that equals 87.39. And then I subtract, I'm just going to subtract 90 because I know and then my answer, I get 2.604. And that is the direction that it's going. The plane will end up flying 2.6 degrees off course. And that's the answer to this problem. All right, so here, let me just write it in. So this would be 2.6 degrees, and this one was the magnitude of it, so 6.22. Usually if I don't know what to do in these problems, I just think, okay, let me find the magnitude and the angle that are associated with the resultant vector, and maybe that will find me some of the information that I need. All right, have a good day. Bye.